Hi guys, welcome back to the channel. In today's video, we're going to take a look at SQL and AWS Athena and how we can pair those two things together in order to query data that we hold in S3 via the Glue Data Catalog. Don't worry if you're new to SQL, AWS Athena, or even AWS itself. I'm going to take you through every step. All the resources you need for this tutorial are available on GitHub, link in the description below. With that being said, I'd really appreciate a like and subscribe to the channel because it helps me out. Let's jump onto the console now. Well, we'll get started. We'll actually spin up an S3 bucket, get the data uploaded, then do a little bit of theory, and then jump into the queries one by one. Okay guys, that's me signed into the console, and the first thing we're going to do is the setup work. So if you click at the link onto GitHub, you'll see that there's a setup section, and I'm just going to cover these 6 points now in a row, so we're ready to go. It's pretty simple. To set this up, I'm going to work out of the Paris region because I haven't set anything up in this region before, and it means that I'm starting from the same place as you. First thing we need to do is get an S3 bucket set up to use for the entirety of this tutorial. I'm going to click into it, and then I want to go create bucket on the right hand side. Bucket names must be unique within the entirety of AWS, so give your bucket name a name that you will remember. I always call mine my first name when I do these types of things, and then I'm going to call this Athena SQL. Okay, leave everything else as default, that's fine for now, and hit create bucket. This will take a few seconds, and then if I type in Athena, I should get it straight away. Okay, there it is, there's it open. I'm going to copy and paste this onto a new tab because we'll be using it quite a lot and it's nice to have it open in a tab. That's it open. If we jump back onto the GitHub, we need to do two things. We need to create a S3 folder called results, and then we want to upload the data as well. So to do this, we will hit create folder, and I will call this results as I said on GitHub. So just call it results. Keep everything else the same and create folder. Now, we will need to use the data that I have stored on GitHub, which is sitting in the data folder. The easiest thing to do is to go code, download a zip. That'll download everything on the GitHub as a zip. You can see that I've got it at the bottom of my screen here on the left-hand side. If I double click this, it will actually then unzip the folder that it zipped downloaded. So there's the zip version, there's the unzipped version. If I then open this up, you'll see that I have that README, but more importantly, I have this data folder. If I leave the data folder open on this left-hand side screen and I grab my Chrome window here and minimize, I want to jump back onto my S3 bucket. So you can see at S3 bucket level, we're in the S3 bucket. There's the results folder that we've created, and I want to hit upload. Then says you can drag files or folders onto it. We want to drag this whole data folder onto that section. And you can see that it's managed to pick up files and folders, 3 of them in data customers, data employees, and data orders. And there's a .csv in each one. We just need to click upload. This will take a little minute. I'm going to blow this back up full size because we don't need that window anymore. It's succeeded. If we go destination here, data will have 3 folders. And if you click into each one of the folders, you'll see that there's a CSV of each data type sitting in the corresponding folder. So orders has orders. Now, just quickly, if we go back onto the GitHub, you'll see that in the data section, I've actually laid out what this data looks like. So we have customer data, and it's in this format here where there's 4 rows, and there's a customer ID, first name, last name, full name. Inside the orders folder in that order CSV, you'll see that there's a lot more columns, but the data looks like this. If you just look left, you've got sales order ID detail, order date, due date, and so on. You'll then also have an employees folder, and this is all file level right now, but if you opened up that data locally in CSV, it would look like this, where you have ID, a manager ID, first name, last name, full name. The columns, word of warning, the column names are not in the folders currently, and this is to make it easier for us. So the column names will not be in those files inside the folders we just uploaded. It is only the data itself. So I'll repeat that. It's only the data inside the .csvs. We're actually going to use Athena to create these columns for us in tables. Okay, that's that done. So we've done the S3, the results, and the data. Next thing we need to do is set up Athena workgroup, and then we'll take a little look at the console of Athena and we'll create a database. Back onto the very first tab. So I'm going to leave my S3 bucket open on this tab in case we need it. Up at the top, I just want to type in Athena into the drop-down menu and click in, and you can see that we're in Athena. So this is the first time I've been in here, and the first thing we need to do is some setup work so we actually can run Athena. If you go into settings, you'll see that everything should be blank if this is your first time. Hit manage, and the thing you need to do is give it a S3 location of where you want to store the results, and you guessed it, it's going to be this results folder here. So if we go back out and we tick that results and you hit copy URI, so tick results, copy URI, back into here and just paste that in. That's the location where we're going to save our results. Hit save, and that is us with the primary work group up and running. If you are new to Athena, which I assume most of us are, sorry, it's back on the query editor there, there's a couple of things we need to take a look at. The first is that we're always in the primary work group for the basis of this tutorial. It's just the main work group, and the results will be saved to results, where we just set up on that S3 bucket. The other thing is that we will be using the AWS data catalog as our data source. This is a Hive external meta table formed around our data so we can create tables and databases to query. What, Johnny? What are you talking about? Tables? Theories? I didn't sign up for any of this. Okay, so for Athena to work, we actually need a data catalog and a database. So let's have a little look at the theory, and then we'll create a database and finish the setup. Okay, so I've made the presentation for free as well down in the description if you want to download it. Alternatively, you can just follow along. So AWS Athena is an interactive query service that makes it easy to analyze data in Amazon S3 using standard SQL. So we've already uploaded our data to S3, and we're going to use SQL then to analyze it. Athena is serverless, so we don't manage the infrastructure. That's really the important part of Athena. We don't manage the infrastructure. We are literally just typing SQL statements. It uses Presto to run SQL queries. We'll dig in a little bit about what Presto is next. And then out of the box, it's integrated with AWS Glue Data Catalog. This is where we're going to store our metadata. And again, I'm going to run along about what this actually is when the time comes. What is Presto? Presto was developed by Facebook and is now open source. It's a distributed system that runs on Hadoop, uses architecture similar to MMP or MPP rather, database management systems. It's got one coordinator, and then it works in sync with multiple worker nodes. I've left a link down below in the presentation to AWS where you can go read more on it, but at a high level, it looks like this. We type a query into the UI in Athena. It runs off, and in behind the scenes in the AWS Athena service with infrastructure we're not looking after, we have a clustered computer. It runs a Presto engine. It looks up the results in S3 and then returns that results to our actual screen. And the only thing we have to worry about is typing our queries correctly in this screen as analysts. Perfect. But what is the Glue Data Catalog? So I've mentioned before that this is key and critical. So there are AWS Glue videos on this channel that goes into a lot of depth on this, but it's a persistent meta store. It tells us where the data location is, the schema, the types of data, and the data classification if we want. But for the purposes of this lesson in Presto, it's really the data location, the schema, and the data types that we are after. AWS Glue databases. So we're going to create a database to hold our tables, and a database is just a set of associated data catalog table definitions organized into a logical group. So we're going to have 3 tables, and they're going to sit inside one database. So we have a database, and then we'll have 3 tables: customers, orders, and employees eventually when we go through this entire tutorial. So what's a table? So a table is just a definition that represents our data. The data resides in its original store, which in our case is S3. We're just going to put a schema over our S3 data. And funny enough, that schema looks like this. Our table will actually look like this in the catalog. Our data here will sit in S3, but our actual names of columns and types and table name will sit in the data catalog. Don't worry if it doesn't make full sense right now. It will as we go along. So we're just going to now go and finish these setup steps since we ran over a little bit of theory there. We're going to do a console overview and create a database. Back onto AWS Athena, it should look like this. A couple of things just to point out. Our data source AWS Glue data catalog. We don't have any databases yet because we haven't created them, but that's where we're going to logically group our tables. And naturally, we haven't created any tables yet, but that'll happen down the left-hand side. This is our actual query window here where it says query 1, funny enough, and we can type in our queries, and then our query results will appear down the bottom. And these kind of blurred out or cleared out things here won't actually work until we start typing queries. So the first thing we need to do is create a database. So if we type in the syntax create, then database, then we have to give the database a name, and you can see it's in that browny red if the syntax is valid in terms of a keyword. Then you need to give it a name. So I'm just going to call this demo underscore data because that will be the easiest. And then semicolon to actually say I have finished typing my syntax or typing my query. If we run, this will take a few seconds and it's completed. You can see then that we have two databases, default and demo data. Click into demo data on the left-hand side and we're in the database. If you want to have a quick look at the AWS data catalog, type in AWS Glue and you'll see that it comes up. I want to open that in a new link. Click on. It takes a few seconds to load. And you'll see that down the left-hand side, you have the AWS data catalog. And the first thing we have is databases. You can see with the default that came with it, but more importantly, there's the demo data that we just set up. Let's click into that and leave it open because we'll create a table now called customers on the next step. Okay, the next thing we want to do is create a table. So if you look at one, we create the customer table for the Glue data catalog. I have left the syntax here for you to copy if you wish. And then we need to change this location. But because this is the first time we've done it, we'll actually type it out from scratch. So create table. If not exists, then the name of the table is customers. Customers. New line, 2 curly brackets. Then we have to list the columns and their data type. So the first thing we have is customer ID. And we want that as a big int data type. So that's the name of the column, and that is the customer ID. So if we just jump back up into the data section, you'll see that we have customer ID, first name, last name, and full name. We're going to create the customer ID in the data catalog table definition and call it big int. We'll then do first name, last name, and full name, and they'll have type string. So back onto Athena, put in a comma because we're taking a new line, so comma. Then you want first name with type string and then another comma. Then you want last name with type string and then another comma. Then you want full name and you guessed it, type string with another. Nope, actually we don't want a comma. So because we're not putting another line or another column and data type or field and data type, we don't need a comma. So there's 3 commas at the end of each of those lines and none at the last line. Now, there's a couple of other things we need to define in this table definition for it to work. And actually, it's create external table. If not exists, sorry. So I forgot the external. So make sure you put that external command in there. Then we need to define the row format as type delimited. And again, you can see that this is all coming up as keywords. So the brown is keywords. These are data types and reserved words as well. Then we want fields, which I always spell wrong. Yep, fields. Term in. And again, if you don't want to type this all out, it's available in the GitHub. But fills terminated by quotes, comma, because we're CSV files. Space or enter onto a new line rather, stored as, and then all in capitals text file, new line, location, quotes again, single quotes, and we need the data location, which we can get by going to the S3, ticking the bucket, copying the URI, so hit copy URI, and then paste it back in, and then you need a semicolon outside that last quote box, and that should be us. You want to run, and you can see that it was completed successfully. Now, once you've ran the data, you'll want to select the data. So to select all the data, which is step 2 on the guide for the main tutorial, you want to type in select star. So star means give me everything. So select all the columns, customer ID, first name, last name, and full name from the table called customers with a semicolon and run. And you can see that we're able to select customer ID, first name, last name, and full name from the table that we've just created on query window 1. And we're using select star for query number 2 that we're creating here, so we can actually select. So back on the main tutorial, you'll see that we've selected all the columns after creating the table. And the next thing we want to show here is how do we select a column only or one column from the data set. So back into Athena. If we look at query 2, and instead of putting star, we write first name, and we run the query, we're then only selecting the first name column from customers. So you can see that we've only selected first name. And if you want to select more than one column, but not every column, you can put a comma in. So separate the columns and put in last name and run that. And it will select all the first names and all the last names from our data, as you can see. And then if you have a third one, you guessed it, it's just another comma. And you can type in full name, and you'll see that full name comes up now. So we'll have first name, last name, and full name. And then just for completeness sake, order doesn't actually matter either. You don't have to write them out in the order that you see on the table. You can put customer ID last. So let's do that. Customer ID, and then run. And you'll see that you have first name, last name, full name, and customer ID. So that's how you select individual columns. Back on to the GitHub. So we have done how you select all the rows, how do you select a column, and then we want to look at column aliases. So let's have a look at column aliases, where we rename a column as we select it. So delete out everything in the little column section. So from back to first name and the comma. So now all we have is first name. If we run that, let's just check it's working, and we return all the first names. Now, column aliases is where we give first name a new column name, but we still select the data. So the next phrase you want to type is as, and then you want to give it your alias, or the name that you want to pretend is the name. So I'm going to go f_name and run that. And you'll see now that we're selecting as f_name. Simple as that. Let's delete everything back here and just run first name again. Make sure we get the data back. We do. Okay, now we want to concatenate two columns, where we add two columns together and give them an alias. So back onto Athena, and the first name is sitting there. We want to put in front of that concat. So that's the concatenate or add two fields together function. Then we want a comma, and then we want to put in last name, and then we'll put in as full_name. So we're concatenating the two columns together, and we're calling it full_name. Again, it's not creating any columns. This is just for the result set. So you can see that it's added the two columns together, but the eagle-eyed amongst you will see that there's no space. So that's simple to solve. Concatenate can actually take another argument in the middle. So if we put a comma in, and then we put in a space between two single quotes, we're basically now saying, give me first name, then give me a space, then give me last name. So concatenate can take three arguments, and then you end up with the space in between. Okay, next we want to look at a where clause for filtering data. And then we're going to look at actually and or after those clauses. Back onto Athena, and I'm just going to work in a new query window that's blank. So just hit the little plus symbol. On the GitHub, I have only selected first name in the actual query, but for the purposes of demonstration, I'm going to select star so it's easier to see what's going on. So if we do select star rather than select first name, it will make things maybe easier to see. So select star from customers where, I'm just going to do capitals so we can see that. First name is equal to, and again, inside quotes, capital J and John. So this is going to select and filter and give me only the rows where the first name is John. So you can see we have John Arthur, John Adult, John Beaver, John Bennett, John Barry, John Brooks, John Colon, John Donovan, and Emroy, and so on and so forth. Okay, next thing I wanted to show you is that you can filter on multiple columns. So let's say we wanted to filter on last name, and I only wanted then where the last name is equal to Arthur, Then we're looking for every column where the first name is John and the last name is Arthur. Run that and we get one result back. So you can see that there's one person or one record in our table that has John as the first name and Arthur as the second name. Now, let's have a look at the keyword or. So this works differently, where we're looking where the first name is John or the last name is Arthur. So they don't have to be John and Arthur, it's John or Arthur. And as you can see now, we've got all the Johns back with Arthur as the first one. But then we have everyone called John again. And that's just inverse the first name and see if anyone is not called John. Nope, everyone is called John. He has the surname Arthur. Okay, so you can see then that John or Arthur brings us back everyone called John or anyone with the last name Arthur as well. So in this instance, everyone is called John. Okay, the next thing we're going to look at is using the in clause to filter data rather than an equals. It actually works the same as an equals almost. So we're saying give us customer ID equal to 371, and then you can use a comma to separate two customer IDs and get it back two rows. So let's have a little look at that in action. Let's scroll up and go back to the end of the first name and just delete that. And then we want our customer ID in this time. Then you want to put curly brackets as always when we're doing these things, and then we're looking for 371. There's no quotes because the data type is an integer, so it's not string. And then we just want a colon at the end and hit run, and that'll return where the customer ID is equal or in 371. And if you wanted to do 2, then you can just put a comma in place and type in, put a comma after 371 and then put in 377, so 377. And this time I'll get 2 rows back, one for 371 and then one for 377. So it's a different way of doing some filtering using a in clause. Next, we'll take a look at wildcards. Wildcards on step 9, as you can see, is actually in the like clause here, where we're using this wildcard percentage sign as a wildcard for the string. And what this is saying, give me the full name like J wildcard. So give me the full name that looks like J wildcard, which means give me anything that starts with the full name J. So let's think about that again, and I'll read that again. So select star from customers. So select everything from the customers table where the full name is like J wildcard. So give me everything that starts with J. Let's be lazy, and I'll just show you this time because we're going to need it later. If you just copy there and you hit that copy button, delete what's in the query window like so, paste in the new copied and paste and run. And it's going to give us back everything where the full name starts with the J. So you can say we have Jesus, Hernandez, June, Judy, Judal, Joseph, and John. So that's how the wildcard works. And if you wanted anything that started with an M, then replace the J with an M and hit run. And you can see we have Mitch, Mindy, Minsu, Mike. And then that works even further where you can do give me anything that begins with M-I-K and then anything after that. So we should get all those mics back, as you can see. And you can go even further than that and say, well, give me anything that begins with Mike in the full name, like so, with a space and then a C and a wildcard, and we should get that Mike Choi back. That was at the top there. So that's how a wildcard works when we're actually using a percentage sign to say, give me anything after C. So give me Mike, space C, and then anything after that is allowed. So in this case, we've returned an H, an O, and an I. Okay, the next thing we're going to look at is union. So let's take 371 as the first ID we look at. We want to type in select star from customers where customer ID equals 371 and then semicolon and run. And we should get back a row. Now what we can do is take out that semicolon and put the phrase union. Then if we write the same thing again, which is select star from customers where customer ID is equal to 371 and then put in a colon. What we're doing here is selecting the row where the customer ID is 371 here and the row where the customer ID is 371 here, and we run it and you can see that we only get one row back, and that's because this union is deduping the two rows. if that are the same. If we put union all and run this time, it will work slightly differently and give us the 2 rows back. Now this only works because the columns are the same in each statement. So we're selecting these 4 columns and unioning them all to these 4 columns. Now what we can do next is actually put in and write 371, 377 and close. This time we'll have, you guessed it, 3 rows back now, where we're actually working with 3 rows. And if we get rid of the union all to union, then we'll dedupe the first 2 rows and end up with the 3rd row, which means that this is working. Now, as I pointed out, this only works because the columns are the same. So there's 4 columns and 4 columns. If I was to put in, for example, last name here, then we would get an error because the columns are a mismatch. So if I run that, you can see that we get demo database less qualified because different number of fields. We have 1 in the first and we have 4 in the second. But if I was to change this to last name and run the query, then we have 1 and 1. And you can see that that actually worked. It also works if I was to change this to first name, although why you'd want to do this, I'm not sure. And run it, then we would have the last name from the first row of 371 and the first name of 377. However, as you notice, this doesn't really make sense. So what we could do is change this to as first or last name. So we're bringing in that column alias now of as and run, and then it will become first or last name, John and Arthur. Okay, just going to delete that query out so it's blank and back on. Next thing we want to look at is inserting a row. So we're going to insert a row with this ID of 1221. So back onto Athena, and the syntax to insert a row into our data is insert. Oh, Catbox is not working. There we go. Insert into table name, which is customers. Then you want to open a set of curly brackets where you put in the columns that you want to insert into, which is customer ID, first name, last name, and full name. Then outside of the curly brackets, you put values, and then you put in order the values that you want to insert. So the first one is 1221. So 1221, comma, then they want to put in the first name. So that was the customer ID, customer ID. This is in the first name, so I'm just going to call this John or Jane. We'll go Jane for a change. Then we'll put in the next one, which is Doe. And then full name will be Jane Doe. So as you can see, customer ID, first name, Jane, last name, Doe, full name, Jane Doe, and then a semicolon and run. And that'll go and insert the data into our folder down on S3. If you take then the ID that we just created, which is 1221, so copy that, and write select star from customers where customer ID is equal to the 1221, and then semicolon and run, you'll end up actually being able to select the row that we've just inserted. And again, just going to delete that for speed so we can type back in. Okay, so that's inserting a row. Full syntax is there if you just want to copy and paste it. Okay, so distinct is actually a really quick way of getting distinct names. And to see this in action, we actually need to select some names and then make them distinct. So if we write select star from, actually we'll put in first name so it's easier to see. First name from customers where first name like, and then we'll use that wildcard. So we'll go J and wildcard and run. We're going to select everything that starts with J as a first name. So you have J, James, Philip, John, James, Jennifer, Josh, John. And what distinct does is give us back the unique first name. So rather than having a line all the time here for every name that's John, we'll have one line that says John. So if I put in distinct and then run, you'll see that actually it goes down. So now we don't have all those Johns appearing. We'll have it appear once as a John, and that's it. And you can see that everything else is deduped the whole way down there as well now. Anyone keen, eagle-eyed, spot the John? Is it on the second page, maybe? Oh no, we've got one page. Hang on, Control F. There it is, 47. Didn't see it. Row 47 for me, I have John in once rather than multiple times. So that's how distinct works. It's just giving you the distinct values or the unique values for that column. And you don't have to apply it with a where. You can actually do it without the where as well if you wanted to, where you could just run it on all first names. And that's all the distinct first names within the data set. Okay, next we're going to look at count. So say you wanted a count of all the first names that begin with J. Then back onto Athena, it's select, then the keyword count, then open, then the column that we want to count. So first name in this instance. From the table, as always, customers, where first name, and again, we're going to just use wildcards and like. So like J, so count everything where J is the first name, or the first name begins with J, and we have 108 values. Now, the next thing is a nice little bit of syntax where you can get the distinct first names and then count them. So count all the distinct first names is where we actually just put distinct in front of first name. So distinct values of first name and then count those values that are like J. So distinct like J, then count, and there's 49 of them. So that's an interesting one to use the count and distinct together. Comes in handy all the time. Now, let's have a little look at group by. So it's a function where we can group on things, and what that is, in essence, can be shown on the query. So select star, or select, this is easier, select first name from customers, and let's run that first. And run. And again, we're just going to end up with a big long line of all the first names. And they're in there multiple times, so we have multiple Johns. Then what you can do is group by. And actually, to show that easier, what we'll do is where first name, like again, the wildcard of J. So give me all the ones that start with J. This will go down in numbers, but we'll still have multiple lines. Oh, wildcard's on the wrong side there. Like J. So J, then the colon. Okay, so you can see that we have multiple Johns floating around again. What we can then do instead of the distinct is add in group by and type in first name and run. Then we only have the single Johns in again, so you can see that we're back down to that 49 count and everything's in there once. And then as a little extra thing, you can actually do group by and count to see. So you do first name, then comma count first name as count J first name. Just count of all the J's first names. And if you run that, then we're counting all the J first names. So you can see then, if I do this, that James is in there 10 times, Judy is in there 4 times. So there's 4 rows where Judy is the first name. And that's that query there. We're saying group by on first name, but only where first names are like J. So run the query and get me where all the first names are like J. Then group by the first name and then count those first names for me as well in a separate column. Okay, next we're going to look at nested queries. So nested queries are an interesting one where you can write one query and then set that inside another query. So let's do that right now on the console. Back onto Athena, let's get rid of all this. I always write my first query and then make sure it runs and then I write the second query. So let's select customer ID from the customers table. And we need to put a semicolon on and run. And it gives us back all the customers' IDs. Now what we can then write is a second query where we say select star from customers. Customers. Where customer ID in this nested query. So if we put a bracket around these sets of the query and pull it up onto the line, what this is then doing is it's running this query first to get all the customer IDs and then saying, give me all the rows where the customer ID is in the result set of this query. And if I run that, it will return all the rows. The last thing we want to look at here, or the last thing before the joins, is we want to look at common table expressions. So this is a way to write a common table expression where you write a select statement as common table expression, and then you can select it outside of that actual query in one go. So what you do is with CTE as, then define the table. So this time it will be select first name and last name from customers. So we're running this little bit first where we're selecting first name and last name from customers. Then we're actually just going to select all rows from the common table expression from CTE, comma, and run. And you'll see then we get first name and last name. Now this comes in handy if you want to do a little bit of work here, like we could go as first underscore name, and we could do as last underscore name, and then we want to select from CTE as it currently sits like that, and we'll end up with those column names renamed, first name and last name. So that's just a wee example of what you can do with CTE. Okay, before we cover the two types of join, we actually need to create two tables. So this is pretty simple. It's what we did before. It's just over the two other data sources that we uploaded right at the beginning of this. So back into Athena and take a clear query window and paste in the first thing, which is the employees table. If you jump back onto the S3 bucket that we haven't been in a while, we just want to copy that employees URI and then replace where it says table data location with that and paste. And then you want to run. Just take a few seconds and that's it completed. And you can see we now have an employees table added to our glue data catalog down the left hand side. And then we just delete that out. Back onto the GitHub README, and we have an orders table. So you want to copy that orders table, paste it in, and again we need to change that data location. So that orders table is here under orders. Copy the URI, not the URL, same as before. And this time we're just not typing it all out. We're just going to replace that location at the bottom and run. And you'll see that we end up with an orders table in the glue data catalog down the left hand side. So I'm going to get rid of all that, and the next thing we're going to do is do an inner join. Now, if we just scroll back up to the top here and take a quick look, you'll see that we have an orders table, which we've now created, and it has a customer ID. Our customers table has a customer ID, and what we're going to do is join on this where we have 293 and 293. We want to display that as one big long row where the customers and the orders details are together. Then when we have 295 and 295, we want that as one big long row and displayed together, and so on and so forth for all the matches that we have between the two tables. So let's do this quickly back out here. And we just say select star, so we want everything from the start from customers. And just like standard SQL, it's inner join. Orders on customers dot customer ID equals orders dot customer ID, and then a semicolon to finish. So you can see there that's not right. So it's customer.id and run. And you can see that we have a big massive long line where the two customer IDs are the same. So 311 there and 371 there. And you can see then we can start to put the two tables together the whole way down. And that's the inner join. So there's all the John Arthur's orders up first. And this works the same. So if we wanted to only see all the customers where the customer actually only has orders where the first name is John, you can do where first name equals, and like we did before, John. Then this just gives me all the customers that are called John and their orders. And then if I run that, oh, it doesn't like that, where first name is John. It gives me all the orders where the first name is John and then all their order amounts from the customer table, and just use that bar in the bottom right there to slide, and you can start to see all the orders for people called John. Excellent. So that's the two things put together. If I just scroll back up to the top, the last thing we want to look at is a left join. We're going to inverse this slightly. So we're going to start from scratch, and we're going to put in select star from the orders table. Then we want left join, and I'm going to show you what this means in a little second. Left join customers on, and then we're just gonna be lazy this time. I'm gonna copy this. So orders dot customer ID, and then equals to the table of customers, and then copy and paste that dot customer ID, semicolon. What it'll do now is display all the orders down the left hand side and then join in the customers. If there isn't a customer ID in the customers table, it will just display all the orders and then leave the rows blank where they need to be. So that's everything in terms of joins that I wanted to show. If you're familiar with SQL, it's exactly the same. Okay guys, congratulations. That's the end of the video. Well done on sticking it out to the end and running all those different queries. Let me know what you think down in the comments below. I've left a link to my website if you want any more free lessons. Alternatively, you can find them on this YouTube channel as well. Again, I'd really appreciate a like and subscribe. And until next time, thanks for watching.